part 2 of functions, relations, domain, and range. Now we're going to be doing the hard part. Domain and range, when you're looking at a graph that follows some sort of rule that isn't just a bunch of points. So you have to really be thinking about left and right for domain. This is your x values, goes left and right. You got to think about up and down for range. You do that, you got a chance. Okay, we're going to start from negative infinity, from over in this direction, and we're going to approach this graph. Now, I did not intend for these to stop. So it's kind of hard to tell what I mean by domain and range. So I'm going to say, let's suppose that there were arrows. And that means that it's going to go on forever in the direction you see. So I guess we're looking at a function that does this. Quite honestly, that was not my original intention, but that's what we're going to do right now. So this function right here. So coming from this direction, can x be anything? Yes, this arrow is kind of tilted down and to the left. It goes infinitely far down and it goes infinitely far to the left. And on this side it goes infinitely far to the right and infinitely far up. That means that for both of these, the answer is all real numbers. And I'm going to try that again. That's really bad. All real numbers. And I have a shorthand way for writing that. Okay, it is a R with an extra stick at the end. So both of these are all real numbers. That is not the case for this one. It is bounded left and right. It is bounded up and down. It has a min and a max in both directions. So if I'm coming at it from this direction, there are no x's that are over here. But x can be this. And what is that? That looks like 1, 2, 3, 4, 5, negative 5. So x could be bigger than negative 5. And all the way up to here, which is a positive 5. Now, there are no gaps here, and I believe it goes right up to and includes that boundary point, so I'm going to use the inclusive signs, the ones with the equals underneath them. Now, for the range, the minimum value goes down to here. You're approaching from the bottom, nothing, 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 but it hits right here, and that looks like a y value of 1, 2, 3, negative 3, and it goes up to 2. Now remember, there's a y here, so y is between negative 3 and 2. Okay, the next four have a very similar problem set. Identify the domain and the range of this. We could cover, is it a function right now? The answer is no. It's not going to pass the vertical line test. Get that easy one out of the way. The domain and the range, as I approach it from this direction, I don't have any x values, so it does have a minimum. However, does it have a maximum? Well, actually it does, because there's an open dot there and an open dot there. I think you can make that out on the video, and if not, you could probably make that out on the handout. The domain has a minimum value of negative 3. That's negative 1, negative 2, negative 3. So the domain, x has to be bigger than 3. X has to be bigger than 3. Don't like any of that. Let's try again. And that's a negative 3. X has to be bigger than negative 3, and it goes all the way up to 2. But since that is an open point instead of a solid point, it doesn't include the 2. But we don't have any open point here, so I think it does include the negative 3, but doesn't include the 2. So x is between negative 3 inclusive and 2 non-inclusive. So for the range, approach it from the bottom, and there are values here that you just don't hit. We see absolutely everything on the graph because it doesn't have arrows. So it has a minimum value, and that's right here. And that is very difficult to determine what that is. If I brought it over here, Maybe it's negative 2 1/3, maybe it's negative 2 1/4. I'm going to say negative 2 1/4. That is, that estimate is usually not something I'm going to have you do, but if you're close, I'm giving it to you. That is negative 2 1/4, and it doesn't look very good. Bigger than negative 2 1/4. And it looks like it goes all the way up to probably positive 2 1/4. And since those dots are both open, the non-inclusive signs. Find f of negative 2, function notation. So this is an x value, negative 2. So if you draw the line x equals negative 2, and you got to remember that x equals some number is a vertical line, then you see that it hits in two spots. Both of those are answers to what is f of negative 2, and that's also why we have the answer no for is it a function, because there are two answers to this. So it could be, let's see, a y value of 1 or a y value of negative 1. F of negative 2 equals 1, or f of negative 2 equals negative 1. F of negative 3 is this line right here, x equals negative 3, and I think we have one output there. My y value is 0. Now this asks the question in the other direction. Find f when f of x is 1, and remember that f of x is like y, so it's saying something like when y is 1. Y is 1 is a horizontal line, and it crosses right here. So that's an x value of negative 2. Shouldn't be a surprise because we've already seen that as an ordered pair in function notation right here. Okay, we're on to this one, and you give this one a try. I'll do it and we'll come back and we'll discuss it, but do note that there are arrows here. So we got this V-shaped graph, goes infinitely far up to the right, goes infinitely far up to the left. Okay, so I have a domain that is all real numbers, because as far as going left and right, this arrow goes infinitely far to the left, this arrow goes infinitely far to the right, so all values work. The range, be careful if you're going to use this symbol for all real numbers, make sure that you're only using the regular old R for range. The range is going to be all y values bigger than negative 1. Should it be equal to? Yeah, probably. Why? Because there's no open dot there. Coming from this direction, there is no y values that can be on this graph, but once we get here, there are y values from here on up. So the minimum y value is right here, and that's at negative 1. There's 0, negative 1, negative 2. So y is greater than or equal to negative 1. So for the next two questions, I would use this line. Here's a vertical line. Here at f equals 3, there's f equals 0, f equals 1, f equals 2, f equals 3. And then you would plot that point, and you'd see, well, what is the y value? And the y value there is 0. If I plot that point, it's 1, 2, 3 over, 0 up. F of 3 equals 0. That corresponds to the point 3, 1. 3, 1. Actually, 3, 0. 3, 0. 3 over, 0 up. And if I move my vertical line so that x is equal to 2, now I have the vertical line at x equals negative 2. There's my x. It equals negative 2. So I would have this point right here. And if I plotted that point starting at the origin, it'd be 2 to the left and 1, 2, 3 up. Okay, that should be a 3. F of negative 2 equals 3. That represents the point negative 2, 3. Sorry about that mistake, but that one might make it past editing. Find x when f of x equals 1. F of x equals 1. Here is my line, y equals 1. There's line y equals 0. There's line y equals 1. And I want to plot some points. Here's a point, and there's a point. So you can see it crosses 2 times, so there's 2 possible outputs. This would be the point 0, 1. And this would be the point 1, 2, 3, 4, 1. So there were 2 possible x values at an output of 1. Is the relation a function? Yes, it passes the vertical line test. Now take a second and try this one. A couple things to note. There's an open circle. It's a start in both the x and the y direction, and that's an arrow. So it goes on infinitely far to the right and up. Okay, here's what I have. These look like they're the same, but the domain is x greater than -2, and the range is y is greater than -2. So this point right here is the point -2, comma -2. It is the minimum for both the x value and the y value. Anything larger will do for either one. So that's why they look so much alike. And since it's an open point, they're both the non-inclusive signs. F of 4 equals 1, you plot x equals 4. That would be this vertical line right here. Here's where it hits. This is the point 1, 2, 3, 4, 1. So F of 4 equals 1 represents the point 4, 1. This one's a little bit trickier. F of -1, and let's see, a vertical line through x equals -1 is right here. So we're looking at that point. Now, was I convinced that that is exactly a half? And the answer is yes, and the slope provides a clue for us. You'll have to remember slope from Algebra 1. It's rise over run, and I see points that hit the grid lines here, 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 and here. So from this point to that one, rise 1, run 2, rise 1, run 2. So that means that this was rise a half, run 1. So it is, the y values are always going to be in increments of halves for a slope of 2, so long as the y-intercept is a whole number. And it is. So -1.5, this point right here is the point -1, -1.5. -1, comma, -1.5. -1, comma, -1.5. So f of -1 equals -1.5. Find x when f of x equals 0. That's like the line y equals 0. That's this line right here. Crosses right there. That's the point 1, 2, 0. So the point 2, 0. There was only 1 this time. X is 2. Is it a function? Yes. Passes the vertical line test. Okay. Last one, and it's not too much harder than any of these others. This arrow here says it goes infinitely far left, and it also is slanting down a little bit, so it goes infinitely far left and right. This one says infinitely far left and down. This side, infinitely far up and the right, which means that the domain is all real numbers and the range is all real numbers. Why? Because it goes, for the x value, infinitely far left and right. For the y value, infinitely far up and down. F of -1, plot x equals -1. It looks like it hits right there. So that looks like it's the point -1, -1. So -1 goes there. F of 0 goes, it's right here. It hits at the origin, and that's the, well, point 0, 0. Find x when f of x equals -1. That's a horizontal line through -1, so it would be here. And look, we hit this point again, so that's just this point over. So f of -1 equals -1. So the answer is -1 for this one, just like it was for that one. And the last question, is it a linear function? Well, no. It's a function, but it's not a line. So function, yes. Linear function, no. Alright, that's it. Hopefully that gives you enough practice so that you can go on and do the practice handout on your own and then check that.